Now let's look at this question on ionic reactions. Ionic reactions occur between metals and non-metals. And metals donate electrons and non-metals receive electrons. The idea is that all atoms want to be stable, like noble gases close to them, and have full outer shell electrons. Because metals have fewer outer shell electrons, they lose them to non-metals, which have more outer shell electrons, but they are not stable. So metals will lose the outer shell electrons or the valency electrons so that the remaining shell is full. And non-metals gain electrons so that they fill up their outer shell. For a dot and cross diagram to illustrate the ions formed in the reaction between magnesium, which is a metal, in group 2, and sulfur, which is a non-metal, in group 6. Magnesium has 2 electrons on the outer shell, so magnesium will donate these 2 electrons to sulfur there. And then it loses that outer shell, and then the inner shell now becomes full. So this is how it happens. So this is magnesium atom, this is a sulfur atom, so we have magnesium reacting with sulfur to give magnesium sulfide. So the naming system is we start with a metal, then non-metal with a suffix IDE. Magnesium is the metal, sulfur is the non-metal, and we add an IDE. So we choose, say, crosses to represent electrons in magnesium and dots to represent electrons in sulfur. So we can see here what happens is magnesium donates these 2 electrons to sulfur so that this shell, this outer shell, which has 6 electrons, will now have 8 electrons and it's full. And it's now stable, like noble gas will have a noble gas electronic configuration which is stable. The magnesium also have a stable configuration because the remaining outer shell is now full. So metals donate electrons, non-metals receive electrons. And the charge here on magnesium, since it has lost 2 negative charges, it becomes 2+ because it has more protons than electrons. This sulfide ion formed now has 2 extra electrons. Now it becomes 2- because electrons are negatively charged. Adding 2 electrons will give it a 2- charge. Let's look at B, potassium and chlorine. Potassium has 1 electron in its outer shell. Chlorine has 7 electrons in its outer shell. So potassium atom will donate its outer electron since it is the metal, and the chlorine, since it is a non-metal, it will receive that electron. Now, the potassium ion formed has lost 1 electron, so it has more protons than electrons. Its charge will be 1+ or +1. And the chloride ion formed will be 1-. So this cross here is representing the electron that is coming from the potassium. And it's giving a charge of -1 here. So we can say potassium reacts with chlorine to form potassium chloride. Remember, our naming system is the metal part and the non-metal part with the IDE. Now let's look at C, lithium and chlorine. Lithium has 1 electron in its outer shell and it's a metal, so it will donate that electron to the chlorine atom, which has 7 electrons and needs 1 electron to fill its outer shell. So the lithium will remain with a stable electronic configuration of the nearest noble gas, which is helium, which has only 2 electrons in the first shell, and the chlorine ion will have 8 electrons in the outer shell. Now the charge here is 1 plus, and the charge here is 1 minus. The electron lost is a negative charge, so the charge will be 1 minus. So we can say lithium reacts with chlorine to form lithium chloride. And lithium chloride, potassium chloride, magnesium sulfide are the ionic compounds formed from the atoms. Let's look at calcium and oxygen. Calcium has 2 electrons in the outer shell, and it's a metal atom. Oxygen is a nonmetal atom with 6 electrons in the outer shell, so it needs 2 electrons to fill up this shell. So what will happen is calcium will donate these 2 electrons to oxygen, and we have a calcium ion with a charge of 2 plus since it has lost 2 electrons, and the oxygen ion with a 2 minus since it has gained these 2 electrons. Now the word equation is calcium reacts with oxygen to form calcium oxide. So this is a simple equation where we put the symbols. This is a structural equation where we use dot and cross diagrams to show the reaction, and this is a word equation. So that is how ionic reactions take place. They only take place between metals and non-metals, where metals donate, non-metals receive electrons. Thank you.